Hello and welcome to another session in supply chain management. As you can see on the screen, we are talking about inventory management. And you might be thinking that, we have had one session on single period inventory. Then, what is this all about? Well, this is really the other side of inventory where we are talking about infinite planning horizon, which means that you keep ordering your inventory and receive and then consume and then again order and again receive and again consume, and this cycle goes on and on and on. So that's what we are going to discuss in this particular session. Well, in the first module, what I have done is that we will be just kind of walking through some of the very basics of inventory management, just to kind of come up to date before we kind of dive more deeply into the topic. So what do we have here? Okay, so the first thing that we start with is that, on one hand, we have said that inventory is a waste. It obviously incurs cost and is responsible for a number of inefficiencies in the supply chain. And yet, at the same time, we know that we can't do without inventory, absolutely. And therefore, the obvious question that we are going to discuss is that, what is the purpose? Why do we need to carry inventory? And interestingly, there are a few different reasons why we carry inventory, and at least three of those principal reasons is what we'll take a look at here. So the first reason or the first purpose of holding inventory is that there are fixed costs involved in the supply chain, and the moment you have fixed cost, you would want to minimize the allocation of that fixed cost on a per unit basis, and therefore you would want to carry some kind of let's say batch or lot. So just to give you an example, when we are ordering an item from a supplier, we don't order one piece or two pieces. We order in some quantity. And why don't we order one or two pieces? Because if we order one or two pieces and keep getting one or two pieces whenever we need the item, then our inventory levels are very low, and that's beneficial for us. But then the reason why we don't order one or two pieces is because every time we order, there is a fixed cost of ordering, and one or two pieces ordering means that you are ordering a large number of times in a given period, and therefore your ordering cost is very high, and that's a fixed cost. So you would want to minimize or rather optimize the allocation of the ordering costs on a per unit basis, and therefore you would want to go for a certain size of the order. Now, this is something very similar that we see or observe in our day-to-day purchases. For example, when you go to buy rice, rice comes in certain sizes. Okay, when you go to buy let's say detergent or shampoo, they come in certain sizes. And the sizes are there only because if you keep buying small quantities of these things, then it's a hassle. How many times in a day will you go to the shop to buy sachets of shampoo or small tubes of toothpaste? You would rather buy a size which is going to last you for at least 15-20 days or a month. So that's the concept that we are talking about, and this inventory that we carry because we want to take advantage of economies of scale is what we call the cycle inventory. And the figure that we see here is something that we are very familiar with. We have seen this in the context of EOQ, and the Sawtooth variation of inventory with time represents what? Let's be very clear. We are saying that we received some quantity here. Now, the moment we receive a quantity all together, then obviously my inventory level goes up, to a certain value, the maximum. Okay? And thereafter, the inventory keeps coming down. And the reason it keeps coming down with time, by the way, this is the time axis. And the reason it keeps coming down with time is because it is getting consumed. And why is it getting consumed? It's getting consumed because there's demand. And therefore, the slope, the slope of this line represents the rate of consumption, or it represents the rate of demand. And truly, this is what we are seeing here. So the inventory is getting consumed, and it reaches zero. And why does it rise up again? Because we have received another consignment, another quantity. So therefore, we are saying that this is the size of the order that we receive each time. And I talked about infinite planning horizon because this kind of continues forever as long as you are procuring this item. Okay, so that's the concept of the cycle inventory. And more specifically, if your order quantity is Q, then the average inventory that you carry at any given point in time is Q by 2. And the cycle inventory, what we call the cycle inventory, is actually this average inventory. And in this case, in a very simplistic situation, we say that it is Q by 2. And one more thing I just wanted to clarify at this stage itself is that please understand that my Q can be anything. The quantity that I'm ordering, look at the green graph. Okay, the green graph, my Q is here till this point. I'm ordering this size of the quantity every time that I order. And obviously it is getting consumed. This represents the slope, which is the rate of consumption. And then again, I receive that quantity and so on. This is something that we have seen just now. However, please understand that I can order a quantity less than Q, let's say the red line that we see here, I can order less than Q each time. But if I order less than Q, my frequency of ordering goes up. And the reason it goes up is because my demand is the same. Whether I order 1,000 units each time I order, or whether I order 500 units each time I order, or 100 units, is my choice, frankly. But then, if the consumption is 1,000 units per week, that consumption of 1,000 units per week is independent of how many pieces I order every time I order. So we have to understand this, that the Q, the size of the order, is a variable in control of us. We decide that quantity Q, but the demand is something that is given to us. And that demand is the same. So what is representing the demand here? I told you that the demand is the slope of the curve, and therefore you see the slope of the curve, whether you talk about the red slope or the green slope, it's the same, because the demand obviously has to be the same. It doesn't matter how much quantity you're ordering each time. Okay, so this is something very interesting. Related to this is another very interesting concept. And that concept is that, suppose I asked you that what is the average demand per cycle? Okay, now what is a cycle? Well, this is a cycle. This is a cycle. These are cycles. So this is 1 cycle, 2 cycle, 3, 4, and so on. You can call them periods also. Whether you call them cycle or periods, it's the same thing. So my question is that what is the average demand or consumption in 1 cycle or in 1 period? And the answer to that is this quantity Q itself. Your order quantity Q is actually the average demand for this period. Because Please see, this is the start of the period. You receive Q, and at the end of the period, you have consumed all Q. And therefore, what is the demand for that period? It has to be Q. So this is something that fundamentally we need to understand, that the average demand during the cycle or during the period is equal to the quantity that you order. It doesn't matter what quantity you order. For example, if I look at the smaller quantity, the smaller quantity represented by the red triangles, then we will find that the cycle also has reduced. The period has reduced. So the average demand for that period is this. Okay, you order something bigger when the cycle or the period increases, and the average demand for this is this, because that is the total consumption that is happening during that period. Okay, good. So we move on. This is the concept of cycle inventory. We next come to, we were actually discussing, what are the reasons why we carry inventory, and the next one is something that we are all familiar with. We say that, there's a lot of uncertainty in demand or in our supplies. And whenever you have uncertainty, you need to safeguard against that uncertainty by keeping something extra, what we call a buffer. In this case, we call it the safety inventory. Okay, so here we are, suppose, very similar situation as we saw in the previous slide, with the slight difference that I have a band, I have kind of a buffer stock called the safety inventory, and the demand is really not constant. I mean, if you see the slope of the demand here and the slope of the demand here, they are not the same, So the demand is variable, and sometimes you kind of eat into your safety stock, and sometimes you may not, or the amount of safety stock that you deplete in a cycle varies. Okay, and we'll come to that later in greater detail. So basically, we are carrying safety inventory because we want to safeguard against the uncertainty that is there in the supply chain, primarily in the demand and in the supply. There are supply-related uncertainties. What if there is a strike in the plant? Production has to be stopped. What if there is a natural calamity which obstructs either production or shipment or transportation? There are delays on the routes of transportation and so on and so forth. So there are supply-related uncertainties as well. And so there we are. One thing that we need to understand is that what is the quantum of safety inventory that needs to be carried, and intuitively we will perhaps agree that greater is the uncertainty, greater will be the quantum of safety inventory that you will carry. And also one more factor, which is the supply lead time. The longer is the supply lead time, the greater will be the need for safety inventory. And the reason for that is that, you have sent out an order to your supplier, but the supplier is going to take a long time to send you those supplies, and therefore, the uncertainty is more simply because it is for a longer duration. So the total uncertainty is greater, and therefore you carry greater safety inventory. Good. Now we come to the third kind of inventory, or the third reason why we carry inventory, and this is something that we just can't do anything about. This is what we call the inventory in shipment, which means that, at any given point in time, there are goods which are traveling, they are in transit, and they are on the roads, or they are waiting somewhere to reach the point where they are required, and therefore, this is what we call the pipeline inventory. Like I said, there's nothing we can do about it. We can, of course, try and improve the flow, of goods so that our pipeline inventory reduces. For example, in India, with the implementation of the GST, a lot of these, state-level entry barriers have been dismantled, and we are hoping that the flow of goods from point A to point B, especially if they lie in different states of the country, will be much smoother and much quicker, and hopefully, therefore, the overall pipeline inventory will go down. So that brings us that, what is the pipeline inventory dependent upon? And we are saying that obviously it is dependent upon the average demand. The greater is the demand, the greater will be the pipeline inventory. And of course, it is dependent upon the supply lead time, which means that longer is the lead time, the more is the pipeline inventory that you carry. So fairly simple to understand. So those were the three kinds of inventory representing the three reasons why we carry inventory. And now I very quickly come to an overview of the economic order quantity model that we are all familiar with. This is just an overview. We had certain assumptions, and they were primarily what you find here on the screen. Infinite planning period, the demand, infinite planning period, I just explained what we mean by that. And the demand is constant, continuous, and known, which means that the demand is perfectly deterministic. There is no uncertainty in the demand. Then we said that there were no shortages allowed. And why should they be allowed, you might think, because, if I know exactly what the demand is, then I would, and there are no uncertainties actually, then I would supply exactly what the demand is, and there would not be any kind of stock out or, shortages. So that is something that we have assumed here. And the final thing that we are saying is that the supply lead time is known and constant. So with these assumptions, let us look at the model. By the way, any inventory model or any inventory policy, we must decide two things, okay? How much to order and when to order. The moment we know both these things, then we are absolutely fine. We have decided the policy. We don't need to do anything else. Okay, so what do we do? Here, perfectly known demand. So you can see that the slope of the demand curve is constant. It's a straight line, and we are ordering a quantity Q. The Q reaches here and again here and again here, and the cycle keeps on repeating. Okay, now when do we order? Now here is the lead time. So we must order at this point in time so that we receive the supply here, because this is the lead time. So we say we order here. But what is this here? I don't have a time scale which tells me when to order. So the better approach to say when we order is that we say, when the inventory falls down to this level is when we order. This is called the reorder level. And the reason why we are saying it falls down to this level we order is because then whatever is this level will last for the L periods of the lead time. Okay, so that is the reorder level or the reorder point when we order. And if we bring in the numbers, we are talking about the total cost. The first equation here, TC, is the total cost. C is the unit cost, per unit cost, and D is the annual demand, and therefore C times D is the total purchasing cost for the year for the item that we are discussing. CT is nothing but the ordering cost. This is the cost per order. It's a fixed cost independent of the quantity that we order. CT, because I call it the transaction cost. CT is the per order cost, and because we are talking of annual period, we need to find out the total ordering cost for that period, and therefore per order cost has to be multiplied with the number of orders placed in a year. And if the annual demand is capital D, and every time we are ordering a quantity Q, Obviously, the number of orders in a year is D by Q. So therefore, CT into D by Q. CE is the unit inventory carrying cost per year. We must understand that CE that we are talking about is for a year, per unit cost of carrying an inventory for a period of 1 year. And that multiplied by the average inventory that we carry any given point in time, so that is Q by 2. And this is also the cycle inventory that we talked about. So this is our total cost. Then we had talked about something called total relevant cost, where we ignore the first term, C times D. And the reason we ignore that is because, relevant to what? We are trying to find out the order quantity Q. Okay, what is the optimal order quantity Q? And therefore, we are saying that, CD, this term, does not have Q at all. It's a constant. So whatever be the value of Q, CD doesn't vary, and therefore, in trying to determine the optimal Q, CD doesn't contribute anything. So we remove CD from our equation, and we call this the total relevant cost, which is the second term plus the third term. If you look at these two terms, both are functions of Q. The first, this one is CT into D. These are constants. The only variable is Q. So the first term is varying as, inversely varying as Q, and therefore this blue line, as Q increases, that term decreases. The second term is directly varying as Q, and therefore a linear line for the holding cost, and the total relevant cost is the sum, which is, the red line that you see. And as you all know, that it does have a minima. The minima corresponds to a quantity, order quantity, which we call the Q star or the EOQ. And that Q star, you may be well aware, is equal to square root of twice the ordering cost multiplied by the annual demand divided by the inventory, annual inventory carrying cost per unit carrying cost. Okay, per unit carrying cost is also written as H times my unit price or the unit cost, where H is what we call the annual inventory carrying rate. You might have seen typical figures of H would be, say, 20% or 25% or so, So that is the annual rate of inventory charge that is applicable. Okay, so I think this is something that we are all very familiar with. I am just going through it simply because we want to, kind of recap what we already know. One very important thing about the EOQ is that, you may be tempted to believe that the EOQ is of no use in the real world because of the unrealistic assumptions about the demand that it makes. Because we are saying demand is absolutely constant, known, continuous. Where in the world would you find a demand like that? You will be surprised to know that EOQ is one of the most widely used inventory policy. Okay, and the reason for that is because the EOQ is very, very robust. It's a very robust method. What do we mean by robust? So let's understand what do we mean by robust. So here is a graph of the total curve, the total cost curve, that we had seen in just the previous slide. And what is interesting is this flat bottom of this curve. What it means is that this is your actual Q star, the theoretically calculated Q star, but because of the errors in demand and your forecasting errors, etc., etc., even if your estimation is a little bit off, than the ideal value or the real value of Q star, you don't lose much in terms of the cost. Look at when you move away on this side by 20%, or you move away on this side by 40%, the difference in the cost is not even about 5%. So you're moving away 40% from the ideal or the theoretical Q star, and yet your cost, the total cost, is still quite the minimum. It has moved away from the minimum by just 5%. So that is the reason why the EOQ is a preferred method, because it is so simple. So it is simple, it is robust, and that is the attractiveness of the EOQ model. Well, that brings us to the end of our discussion for this module. What do we do next? Well, like I said, we need to move into the real world. So we will introduce, somewhat some kind of variability in the demand, which will represent uncertainty, and then we will look at the continuous review and the periodic review policies with probabilistic demand in the coming modules. Thank you.